Gentlemen, we have a very important client coming tonight. She is the CEO of the endocrine system, and she has a new product that we need to advertise for her. What is it? She came out with this new gland. It's called the parathyroid gland. Well, that's just a tongue twister. How are we supposed to advertise that? That just sounds like a crappy offshoot of the thyroid gland. Gentlemen, I have been doing some research into this gland, and it is the single most important gland in the body. It is our job to show Ms. Stukal and the entire American population why this is the case. Now, do we want this account or not? This would be our greatest account yet. They're in every single household in America. Well, in that case, we should get to work. Very well, let's get started. Ms. Stukal, I'm very impressed with your product. Armen and I have spent several hours researching and coming up with slogans and designs.
Gentlemen, I have no doubts in your abilities. That's why I chose Sterling Cooper. I want the parathyroid glands in every human body by the end of this quarter.
Our advertising campaign can make that happen. The parathyroid glands have only one job, to regulate calcium levels in the blood. Many glands have several functions. Think of it like a handyman versus a master craftsman. One can do many jobs well, which is fine, but the other has spent years and years cultivating his craft, improving his skill, and trying new approaches. He's the best at his job, and his product does its job like no other.
I like that, but I feel like you're dumbing it down too much. You need to understand it in depth. I prepared a folder with some handouts for you guys.
Thank you.
As you can see in the handouts in front of you, I have typed up all the information you will need to know about the parathyroid gland. I've also made a presentation I would like to show you on this topic. And so, for the parathyroid gland, as you can see in this bottom right image, you can see that there are 4 parathyroid glands, and then there's 2 on each side of your neck. Now let's delve a little deeper into its structure. So we have the parathyroid glands are 4 small oval-shaped glands in the neck, and they're located behind the thyroid gland lobes, as you can see here in this image. And so they're about the size of a small grain of rice, so diameter is 3 to 5 millimeters, and weighs about 30 to 60 milligrams. And so for function. The main function of the parathyroid glands is to produce parathyroid hormone, which regulates calcium levels throughout the body and can be released via a negative feedback loop. And so stimulates a variety of things, including it increases blood calcium by signaling bones to release some of the calcium stored and allows it to enter into the bloodstream. It also stimulates intestines to absorb calcium from food, and therefore stimulating cells in the kidneys to transform weaker forms of vitamin D into the strongest form capable of absorbing calcium from intestines. If calcium levels are high, parathyroid hormone secretion increases. And so release of calcium from the bones into the bloodstream increases vitamin D production from the kidney, which ultimately increases absorption of calcium from the intestines. However, if calcium levels are high, parathyroid secretion decreases. It acts on kidneys to prevent loss of calcium in the urine and increases vitamin D metabolism. And also a fun fact about parathyroid hormone, it can also be stimulated by magnesium, not just calcium. However, for the sake of this ad, I would like to stay focused on calcium.
Ms. Sukal, can you just please clarify the relationship between PTH and calcium and vitamin D and PTH?
I apologize if the image is a little bit blurry, but this is just a general idea so you can understand the flow and how everything correlates to each other. And so, as calcium levels decrease, it signals to the parathyroid gland, which causes the release of parathyroid hormone. And so parathyroid hormone impacts both the kidneys and the bones. And so from kidneys and bones, you have both calcium and phosphorus excretions and absorption and resorptions. And so phosphorus is excreted, as you can see here in the diagram, but since I mentioned before, I don't want to focus too much on magnesium for the sake of this advertisement. I'd rather not focus on phosphorus either. The main focus is calcium. And so we want to, as you can see here, parathyroid hormone, when it targets the kidneys and the bones, it leads to an increase of calcium. The same thing happens in the gut. However, the signaling system is a little bit different because it starts with vitamin D3. And so we absorb vitamin D from UV light. However, it needs to be converted into its proper or strongest form so that it is able to absorb calcium. And so this form is labeled here. And as you can see, in all ways, the parathyroid hormone and vitamin D can increase calcium. And so therefore, as you can see, parathyroid hormone directly impacts calcium by increasing its secretion. Parathyroid hormone and vitamin D, on the other hand, have an additive effect on calcium rather than a direct effect on each other. And so, for calcium, the normal range of calcium is roughly 8.5 to 10.5 milligrams per deciliter. And it is used in 3 organ systems: nervous, muscular, and skeletal. And so it has 3 main functions, and that's to conduct electricity, provide energy for muscle contraction, and maintain bone density and strength. And so calcium is considered to be the most important element in the body because it has its own regulatory system, which you won't see with any other element. And it provides, and just to go over this one more time with the functions, it provides electrical energy for nervous system and conducts signals across all nerves. Skeletal system stores calcium to make sure the nervous system has enough calcium to function properly, and allows bones to maintain their bone density and strength. And it's important to note that's in that order. Bone density and strength comes last. Nervous system and muscular systems are prioritized.
Okay. Now, why do the nervous and muscular systems take priority over the skeletal system in terms of calcium use?
The nervous and muscular systems are more essential to survival of an individual. The nervous system sends signals to the rest of your body for every essential function, even something as simple as needing to breathe. The muscular system is important for essential functions as well. For instance, muscle contractions in the heart to keep our heart pumping. While movement is important, it is not as prominent a factor in survival. And so just to understand, since nervous and muscular systems are considered to be the priority in terms of calcium and where it goes mainly before bones can absorb it, I wanted to go over the nervous system first. So in the nervous system, you have an action potential that reaches the presynaptic terminal. And so depolarization of presynaptic terminal opens ion channels and allows calcium into the cell. And so this calcium that enters into the cell triggers release of neurotransmitters from vesicles, which leads to neurotransmitter binding to receptor sites on postsynaptic membranes, and the opening and closing of channels, which leads to a change in the postsynaptic membrane potential. As the action potential propagates through the next cell, you have the neurotransmitter being either inactivated or transported back into the presynaptic terminal, depending on how much calcium is needed within that instant. As for the muscular system, here we have a comparison between relaxation and contraction. So during relaxation, calcium is reabsorbed at the beginning relaxation cycle, and ATP is required for that. And so as you can see here, the thick and thin filament interaction relaxes and muscle lengthens at this point. However, with contraction, an action potential arrives at the neuromuscular junction, and ACH is released, which binds to receptors and opens sodium ion channels, leading to an action potential in sarcolemma. And so this action potential travels along the T tubules, and this all causes calcium to be released. And the release of calcium signals troponin and for the thick and thin filament interactions, which lead to muscle contraction. And so at this point, the muscle shortens, and produces tension, which leads it to contract. However, as much as I've talked a lot about the functions of parathyroid hormone and why the glands are important due to its secretions, it's important to also mention its importance in terms of disorders associated with parathyroid hormone. So what would happen if there was a lack of this hormone or an excess? So hypoparathyroidism. So before we delve into this, parathyroid disorders lead to abnormal levels of calcium in the blood, and they can cause brittle bones, fatigue, kidney stones, and weakness. And so this is true for both types of both disorders mentioned here, hypo and hypoparathyroidism. However, they each have more specific side effects. And so hypoparathyroidism is a lack of calcium and can impact muscle and nerve function. It most often occurs due to neck surgery and is due to removal or damage of gland or blood supply. However, there are other contributing causes such as lack of magnesium. And so symptoms of this disorder are usually tingling or burning, muscle aches or cramps, and spasms in the muscles. And so two possible side effects that are associated with hypoparathyroidism are cardiac arrhythmias and dilated cardiomyopathy. As for hypoparathyroidism, too much production of hormone due to benign tumor, usually one of the glands, is typically the cause of this disease. And so it typically occurs in individuals that are roughly 50 to 60 years old, and is more common in females than males. And so symptoms of this disease are depression, weakness, tiredness, and a few more that are relatively indistinguishable from other diseases. And so it leads to this disease can lead to bad osteoporosis, and unless the bad gland is removed, this osteoporosis can lead to other diseases. And so osteoporosis can lead to fractures, kidney stones, decreased kidney function, heart disease, pancreatitis, increased acid secretion in the stomach, and ulcers. And so let's delve a little bit deeper and see where the connection is and how all this can happen. So loss of bone density may cause fractures to occur. Next, kidney filters impurities out of the blood and by collecting them to form stones. And unfortunately, the most common impurity is calcium. So when you have excess calcium, you end up forming kidney stones. If kidneys aren't making enough vitamin D to keep up with the calcium production and absorb it, it won't be able to function as well. Next, the parathyroid hormone acts on G protein-coupled receptors that impact cardiac myocyte contractility, proliferation, and hypertrophy. So too much parathyroid hormone may cause a variety of heart diseases, some of which are actually also mentioned are also true for hypoparathyroidism. So just because I mentioned 2 heart diseases there doesn't mean that those are the only ones possible. And so as for pancreatitis, patients rarely develop this disease, only about 8%. However, nonetheless, it is a disease that is known to be a side effect of increased levels of parathyroid hormone, so I wanted to bring it out there. And finally, for cancers, increased calcium levels may and for the ulcers, increased calcium levels may increase gastrin and acetylcholine levels, which may cause ulcers. Surgery to remove the gland is required, but hard to diagnose because the symptoms are similar to many other diseases. Usually it's only one gland that is abnormal. However, that's not to say that the multiple parathyroid glands it might not be multiple parathyroid glands that are being affected, and that 2 or 3 of them may not be abnormal. And lastly, if a bad gland is not removed, excess calcium levels can lead to future cancer such as breast, colon, kidney, and prostate cancer. And typically for all these cancers, since it starts at the parathyroid gland, one way of diagnosing it is if you find a lump in the neck. And if you do, that typically is a signal of not only hyperparathyroidism, but a sign that it could possibly have developed into something a lot more serious.
Now, Well, your presentation is great so far. I just have a couple more questions. So, is hyperparathyroidism more common than hypoparathyroidism? Does hypoparathyroidism have fewer disorders associated with it than hyperparathyroidism?
I'm not sure if I'd say hyperparathyroidism is necessarily more common. However, there are more disorders commonly associated with it than there are with hypoparathyroidism. However, that's not to say the disorders I have listed for these two conditions are the only disorders associated with these conditions. So, like for hypoparathyroidism, I only mentioned two disorders that are associated with it. However, that's not to say there aren't any more. These are just the most common ones. Unfortunately, with osteoporosis, there are a lot of common side effects. And since I emphasize osteoporosis so much, I wanted to show an image to compare healthy bones to bones with osteoporosis. And so, as you can see, a healthy bone would have the compact bone on the outside, and it surrounds the spongy bone. However, if you compare it to the bone with osteoporosis, the bone density is completely different, particularly in the compact bone. However, it's more noticeable in the epiphysis than in the diaphysis. Do you guys have any questions?
No, you've given us a wonderful presentation and a great deal of information to work with. Why don't you give us a week to work on a proposal and we could schedule a meeting for the same time, next Tuesday?
Sounds good. I can't wait to see what your team comes up with.
Wonderful. Ms. Stuko, as always, thank you for your time.
Thank you.
Ms. Stuko, I know you are a woman of great importance. Your presentation gave us so much wonderful material to work with. I will not waste your time. Let's get straight to the campaign.
Thank you. I look forward to seeing what you have.
Okay, your product, this parathyroid gland, is very important. You've made that clear. My partners and I have made the decision to throw everything we've got into this ad campaign. TV commercials, posters, radio ads, all with one tagline. Your product is indeed very complex, but our job as ad men is to simplify it and present it in a way that people will understand. Let me hand you off to our artwork director. I love the visuals from your presentation last week, but I felt like it had to be more personal. People need to see themselves with your product. This visual I've put together shows the location of the parathyroid glands in the body. You can see it's located in the neck, right on the thyroid gland. The neck is arguably one of the most important parts of the body. You know, you choke, you die. And showing that the gland is there will convey that to the viewers. Furthermore, It's simple and easy to understand, as you can see on the slide. Two labels: thyroid gland, parathyroid gland. Simple diagram, easy for the American consumer to understand. Exactly. This artwork helps customers see the parathyroid gland in their body, which will help with sales. But in addition to seeing it, they need to know what it does and why it matters. This brings me back to last week's meeting. So, like I was saying last week, the parathyroid gland is the master craftsman of your endocrine system. All it does 24/7, every day of the year, is regulate blood calcium levels. And it's damn good at that. Very best. So you may be wondering, calcium, why is that so important? Why is its function so important compared to the heart, the brain, or bones? Well, without calcium, much of the other systems in your body wouldn't work properly. Your muscles wouldn't contract, your heart muscles, your bones would crumble, and your heart and blood would weaken. If your parathyroid gland isn't functioning properly, the very foundation and structure of your body is threatened. Your body is a well-oiled machine, a litany of complex parts and functions that are interconnected. Much of it's powered by calcium. Like oil in an engine, calcium keeps everything going. And the parathyroid glands are responsible for controlling calcium levels. With no oil, your engine locks up. With no parathyroid glands, your body crumbles into disease and disarray. You really think people are going to like being compared to cars? Parathyroid gland, keeping your body strong and connected. Ma'am, you just witnessed creative excellence at work.
Wonderful. This should draw quite the crowd.
Yes, I sure hope so. Let's go back to my office and iron out the details.
Thank you, gentlemen.
Very welcome. Thank you.
Hey guys.
Hey.
So, in case you didn't get the reference, for this presentation we were trying to do a parody of the show Mad Men.
In case you don't know what that is, Mad Men is an excellent Netflix show detailing the saga of ad men in New York in the 60s and 70s. I highly recommend to anyone that wants to watch it. If you found the aspect of advertisement interesting in our video, you'll definitely find it interesting in the show because they do a much better job of it than we do.
And these are our references. Thank you for listening. I hope you enjoyed.
Thank you.